Okay guys, so what we're going to look at today is a different kind of angle measure. So we're going to look at angles and do some similar things to what we did yesterday, but instead of measuring things in degrees, we're going to look at a measure called a radian. And we did that little thing in class to kind of start to explain what a radian is, but we're just going to look at that a little bit more in depth right now. Now if I have an angle in standard position, like this green one that's listed here, originally, the way we measured this was that theta in between the initial side and the terminal side was the number of degrees for that angle. Well, what we looked at in class, though, is if instead of looking at that angle there, we looked at the distance of the arc of the circumference of a circle that that angle makes. So what that means for us, I'm going to show you guys online a little picture that will hopefully help this make some sense. And let me just restart this for you. Okay, so I start off with a circle. That red line's going to be my radius, and my radius obviously is showing my circle. So what it's going to draw here now is it's going to take that radius and it's going to fold it over on the circumference of the circle. That distance that it created, that one radius took up on the outside, that distance is 1 radian. Now you can see there's that equivalent degree measure on the inside here. So while that is how we measure degrees, that equal distance on the outside there that 1 radius took off, that's 1 radian's worth of that circle. Now what we looked at in class is how much, oh, it restarted again. Let me restart it real quick for you. So there's my radius, my circle, and then it's going to take that radius, lay it over the circle, and that's going to show you 1 radian's worth of that circle. So if that's 1 radian of my circle, we're going to take that radius and we're going to make 2 of them now. So we'll see how much 2 radians worth of that circle is. Then we'll look at 3 radians worth, which you notice is not quite half a circle. But we know exactly half a circle would be pi radians. So what that means is if pi radians is half my circle, then a full circle is going to be 2 pi radians. And that's going to be the basis of everything else that we're going to do with radians. So 2 pi radians is equivalent to a full circle, which means for us, if 2 pi radians is a circle, then that means that 2 pi radians is equivalent to 360 degrees. Now if you look at this circle over here, let's say for example this radius was a distance of 1. If I wanted to find the circumference of that circle, I know my circumference is equal to 2 pi r. Well, if my radius was 1, in this case, that circumference would be 2 pi. Again, you're kind of hopefully seeing where that 2 pi comes from here. So now, since we know that a full circle is 2 pi radians, in order to find coterminal angles with radians, instead of adding or subtracting 360 degrees, hopefully you guys can see this time we're going to add or subtract 2 pi. And again, we can add or subtract 2 pi as many times as we want to, so I'm going to say plus or minus 2 pi n. Now a lot of the radian measures we're going to look at are going to be in terms of pi, because those work out to be some of the very specific angles that we'll see commonly on something called the unit circle later on. But not every radian value has to have a pi in it. But we're going to take one example. Let's say that I want to use the angle pi over 3, and I want to find a coterminal angle to pi over 3. This is why it's important for you guys to understand how to use fractions, because in order to add 2 pi here, I have to get a common denominator. So if I add 2 pi in order to find a coterminal angle to pi over 3, then I would have to multiply the top and bottom here by 3. Then I can add across the top, and I keep that common denominator. So a coterminal angle to pi over 3 would be the angle 7 pi over 3. I also could have subtracted 2 pi, and again with that common denominator, I would have had an additional coterminal angle of negative 5 pi over 3. Alright, so in addition to coterminal angles, we're also going to look at how to convert between degrees and radians. And it's actually going to be pretty simple because we're going to use that same basic idea that we started with. We know that 360 degrees is equal to 2 pi radians. So what that means for us is that 1 pi is equal to 180 degrees. And we're going to use that idea to figure out how much 1 degree is worth or how much 1 radian is worth. So let's start by converting from degrees to radians. So if I want to convert from degrees to radians, I need to understand what the equivalency of 1 degree is in radians. So let's say I use that value that I know 180 degrees is equal to pi radians. Well, in order to get 1 degree on the left side, I need to divide both sides by 180 degrees. That means that 1 degree is equal to pi over 180 degrees. So in order to convert from degrees to radians, I simply take the amount of degrees I have and I multiply that value times pi over 180. So degrees times pi over 180 will give me my equivalent radian value. All right, same idea about the opposite direction if I want to convert from radians to degrees. So let's say, again, I know that pi radians is equivalent to 180 degrees. I need to figure out how much 1 radian is worth in degrees. So in order to figure that out, I would get 1 radian by itself, so I would divide both sides by pi, and I would get that 1 radian is equivalent to 180 divided by pi degrees. Now that actually, remember, does have some sort of numerical value to it, but we don't need to worry what that numerical value is because we're going to be finding these in terms of exact value for the most part. So what that means for us is, in order to convert the opposite way, if we know radians and I'm trying to turn radians into degrees, I would take the radian value that I have and I would multiply that by 180 over pi. So we're going to look at 2 examples, just kind of make sure that we know how to do both of these, and you'll hopefully by those examples be able to see how it's easy to remember which one goes with which. So let's start by converting degrees to radians. So let's say I have a 90-degree angle, and I want to convert that to radians. Then all I have to do is take 90 degrees and multiply that by pi over 180 and simplify the fraction. And if you guys remember, you can simplify fractions before you multiply by cross-multiplying. So I know I can simplify by dividing both of those by 10, and 9 over 18 I know is going to simplify to 1 over 2. So 90 degrees, after I multiply by pi over 180, gives me pi over 2 radians. So 90 degrees is pi over 2 radians. Hopefully that makes sense to us because we know 180 degrees is half a circle. We know 90 is halfway in between. We also know that pi is half of a circle in radians. So half of pi we list as pi over 2. That's how we write that. Then let's go the other way. If I know radians, let's say for example, I have pi over 6 radians. That's a common one that we're going to see. In order to convert that to degrees, I'm going to take pi over 6, and I'm going to multiply that by 180 over pi. And again, this helps you see which one's 180 over pi and which one's pi over 180, because if you look, by doing it this way, what's going to happen to your pi? They cancel out. So all I'm left with is 180 over 6, which we know simplifies to 30 degrees. So if I'm trying to convert from radians to degrees, I'm trying to cancel out those pi's. If I'm trying to go from degrees to radians, most of the time I'm trying to get that pi at the top, which is why I multiply by pi over 180. So hopefully that helps you guys to remember. Now the last thing I want to look at with radians is just some common radian values on something that's called our unit circle. And we're going to look at this a little bit more, not with the next video, but with the video after that. But what we're going to do is we're going to label these angles in radians. Now we're going to fill them all in during class, but for now I just want to look at a couple of these common ones. One thing I do want you guys to do, I'm going to make these 4 angles here the same color. Then I'm going to make these 4 angles the same color. I'm going to make the 4 middle ones the same color. Whoops, I missed it. And I'm going to make those last 4 the same color. The reason for that is because the angles with the matching colors all have the same reference angle. We talked about that yesterday. The reference angle is the distance between the x-axis and that terminal side. So all those green ones share the same reference angle. All the yellow ones share the same reference angle. What I'm going to do on here is just fill in a few of these common values in degrees. We know this is 90, or sorry, this is 0, this is 90, this is 180, and this is 270. So we're going to go ahead and fill those in with radians because we know what those values are. I know 90 is pi over 2 radians. I know 180 is pi radians. And I know that 270 is going to be 3 pi over 2 radians because it's halfway between pi and 2 pi because my full circle would be 2 pi. We write that as 3 pi over 2. That's something you're going to see very common with these radians. Most of the time they're going to be written as improper fractions instead of mixed numbers. You're not going to see 1.5 pi written very often. You'll more than often see 3 pi over 2 listed. So then what I'm going to do is I'm going to go ahead and fill in a couple of these values for you. This first yellow line is going to be 30 degrees. And we just worked that one on the example. 30 degrees is equivalent to pi over 6 radians. Then this next pink line is halfway in between the 2 blue lines, halfway between 0 and pi over 2. So in degrees, that would be 45. If I were to convert that to radians, or again, think about that as halfway between 0 and pi over 2, that would be pi over 4 radians. And then this green line here, I'll just go ahead and give that one to you guys. That one's going to be 60 degrees, or pi over 3 in radians. And what we're going to do in class is we're going to fill in these remaining radian values. And you guys, we're going to start looking at some patterns so you guys can see some things in common between the green lines, the yellow lines, the pink lines. So don't worry about having this completely filled in. We're going to work on that in class. But I wanted you guys to just see a few of these initial common radian values before we work on them in class tomorrow.